everyone, I'm Bon and welcome to my third daily edition. In this daily edition, I'll be solving a math problem made by time. So this math problem specifically is about probability. Alright, so let's say that person A, let's just call him Bob for now, rolls 3 dice at the same time 10 times, which means that he rolled it 30 times in total. And he gets these results. 1 dot, or the singular dot, 3 times, 2 dots, 4 times, 3 dots, 4 times, 4 dots, 3 times, 5 dots, 10 times, 6 dots, 6 times. So, here are the 3 problems that we need to solve. Firstly, we have to calculate the probability of rolling each number based on the results. Secondly, we would have to calculate the probability of rolling 4 dots, 1 dot, and 5 dots in one go, continuously, not skipping any rounds or turns or rolls. And lastly, the probability of rolling the outcomes of 3. So I'll explain on this one later because it's really complicated. Alright, so let's start with the first one. The first one is calculating the probability of rolling each number. So we do not write in percentage because this would give us like less than 100%. Instead we write like this in order to add it up to 30 or just some part of 30. Alright, so 1 dot 3 times meaning that it's 0.1 of 30 in total because 3 out of 30 is 0.1 or a tenth. So let's just continue the results respectively, meaning I go in order from 1 to 6. 0.1, 0.12, 0.12, 0.1, 0.33, and 0.2. Now, solving the first problem was really easy because I just had to try and calculate the fractions or maybe like the multiplication and division score of each dot. So let's move on. The next problem is that we have to calculate the probability of rolling 4 dots, 1 dot, and 5 dots in one go. Now, in order to do this, we will have to look at this chart we made up here. So firstly, the 4 dots is 0.1. which is a 3 out of 30 chance. Next is 1, which is the same. So 5 is 0.33, which means that now we have the set of numbers 0.1, 0.1, and 0.33. Meaning that we have 3 out of 30, 3 out of 30, and 10 out of 30. Now, let's start. In order to calculate the probability of rolling 4 dots, 1 dot, and 5 dots in one go, we would have to take the 4 dots probability multiplied by the 1 dot's probability and then multiplied by the 5 dots probability, which is 0.1 multiplied by 0.1 multiplied by 0.33, which would give us 0.0033 or less than 1% chance of rolling this. Now, the last problem is kind of complicated because we have the problem that, for example, a cube which is 3D has 6 sides and a dice is similar, which is literally a cube. However, some random guy called Tim blurred out or painted on the sides that were covering, that were showing the 3, the 4, the 5, and the 6 dots. So now, these dots only represent 0. Now, there are 2 dots left and the combination of 4 numbers, which gives us the possible 3 numbers of 0, 1, and 2. Now, what the problem C here wants us to do is calculate the probability of rolling the outcomes of 3, which means that the 3 numbers must add up to 3. For example, we have the 6 total numbers here, which is 0.12, 210, 120, 021, 201, and 102. So these are all the possible combinations that we could make with these 4 numbers, which is 0, the dot 1, and the dot 2. Now, in order to calculate the probability of rolling the outcomes of 3, we have to first calculate what the probability of rolling 0 is. Because it is 4 numbers, it means that it is around 0.66%. Now, continuing 0, which is 0.66%, with 1 being 0.1%, and 2 being 0.12%. If we take 0.66 multiplied by 0.1 and then multiplied by 0.12, we would get 0.00792. So I did it independently, so I think there might be some mistakes, but I hope I could fix them and understand probability more as fast as possible. Now, in conclusion, my answer for A is, respectively from 1 to 6, 0.1, 0.12, 0.12, 0.1, 0.33 or 33, and 0.2. My answer for B is 0.0033. My answer for problem C is 0.00792. So how I got these numbers is because instead of using like really complicated numbers, like how you can get 0.33333 or 33.333 and goes on for infinity by dividing 100 by 3, instead I round up to the closest number in order to get the best estimation of the probability as possible. So that was all for my visualization of the DE3 math problem. Thanks a lot for listening to my presentation. Hope it was really helpful and shows my organization skills as well as my new and very beautiful tie. I have more colors coming in the future, so it could have more variety. So that was all from my 3rd daily edition math problem. Thanks for listening. Have a nice day. And if this is on YouTube, please subscribe to my channel. Bye.